Welcome to the Unit 4A practice. These are the answers. So let's get started. So the first one, you can see that I've given the equation, the function, so you can absolutely go into Desmos or try the graph by yourself and you can practice that. But we're going to get going and work on all the characteristics here. So domain is the first one. And you really can start anywhere, but I'll just start with domain. So domain is the x values, so how far left will the graph go? Well, that's going to continue left forever, and left forever, even though it's not showing it on here, is going to go into the negatives. And that left forever is going to go to negative infinity. So it's going to go to negative infinity, the x values, and how far right will the graph go? So we follow the graph, how far right will it go? And it's going to go right forever, and right forever on the x-axis, because the domain is x values, is positive infinity. So negative infinity to positive infinity. Range, looking at the range of this. What's the lowest part of the graph? So we always go from lowest numbers, smallest numbers to biggest. So when we look at this graph as a whole, where on this graph is the lowest point? Well, that's down below here. That's called the vertex. So in this case, the vertex is the minimum point. So there's a line is an infinite amount of closed points put together. So that vertex is a closed point. And what's the y value? Because we're talking range, the y value is -2. So from -2, and it's a closed point. So a closed point means it's a included bracket, -2. And what's the highest value? Well, this graph is going to go up, up, up forever. Both sides are, it doesn't matter. All it takes is one to cover all the y values. So this is going to go up, up, up forever, and up forever on the y-axis is infinity. And we cannot get to infinity, so it's not included, so it's just parentheses. All right, increasing and decreasing intervals. So we have a graph that's going down and then back up. So first, let's label the graph. So from left to right, we have going down, so that's decreasing to the vertex, so it's decreasing, and then it turns and it's going back up, so that's increasing. So now we have to name the domain of each one of those, each one of the sections, intervals. So this is decreasing from left to right always. So from left to right, where is that coming from? It's coming from the left, the x values of negative infinity. And where does it stop? Decreasing x value. X value, 4. Look up here, the x value is 4. So to 4. You can put a parenthesis or bracket, doesn't matter to me. It's increasing. Where does it start increasing? Well, it starts increasing at 4. Parenthesis or bracket. And where does it stop increasing? To the right forever. It doesn't stop, so that's going to infinity. All right, real solutions. Real solutions just means where's it across the x-axis. So the real solution here crosses the x-axis at 2 and looks like 6. So you can just put 2, 6, that's fine. Y-intercept. Man, I don't really know what the y-intercept is here, but there is a way to know if you're given the function. So to find the y-intercept, you substitute 0 in for x. So substitute x equals 0, because along the y-axis, all those points, like this point here, is at 0, 1, 0, 2, 0, 3. The thing that's in common with all of any graph that crosses the y-axis is the x value is 0. So if you substitute that in, so you put 0 in for each x, you'll end up with 0 squared is 0 times 1/2 is 0. Minus 4 times 0 is 0 plus 6. Well, that's 6. So the y-intercept is 6. So 0, 6. Axis of symmetry, where can you split the graph? And it's right at the x value of the vertex. You can split the graph right here at x equals 4. Minimum, is it a minimum or maximum point? Well, that's a minimum point. This is the lowest. The vertex is the minimum. It's the lowest point of the graph. End behavior, so looking at the ends of the graph. So this end here is the left end is going, x is going to negative infinity. The y value is going up to, so the two directions, it's going left, negative infinity, and up to positive infinity. Negative infinity, y is going to positive infinity. The right side here is going two directions. It's going right forever. So that's x is going to positive infinity. And it's going up forever. So that's also the y value is going to positive infinity. Next, graphing. So now we actually have to graph this. So the first thing I would do is find the vertex. To find the vertex, we need x equals the opposite of b over 2a. So we need to know what a, b, and we can do c if we want. So a, there isn't a number there, so that's 1. B is -2, and c is +3. It's just a good idea just to get c in there. We don't have to have it for this. So x is equal to the opposite of b. Well, b is -2, so it's going to be +2 over 2 times a. So a is 1. And 2 divided by 2 is 1. So the x value is 1. But we don't know the y value. So now we need to substitute x equals 1 into the equation x squared minus 2 times x plus 3. And when we substitute it in, you get 1 minus 2 plus 3. 1 minus 2 is -1, plus 3 is 2. So the y value is 2. So our first point is 1, 2. Now the second thing you need to do is find 2 points to the left and 2 points to the right. So the easiest thing to do here, there's no fraction. The a is not a fraction, so we don't have to look about the denominator like we did in the notes. But I would just take the interval or the integers left and right. So the 2 integers left on the x value of 1 is 0 and -1. The 2 integers to the right of the vertex, the x value is 2 and 3. So those would be the 2 I choose. Closer you can get to the vertex, the better. So now let's substitute these in. So we have, if I substitute x equals 0 into the equation, the function, it's 0 squared minus 2 times 0 plus 3, and that's going to end up being 3. So 0, 3, 0, 3. Let me see the points down here. So 0, 3. And we know that they're symmetrical. Each quadratic is symmetrical about the vertex. So if you think about it, you could draw a little vertical line through the vertex. Hopefully you can see that little vertical line I just drew. Any point to the left of the vertex is going to be the exact same height as any point to the right. So we want 1 left of the vertex, and it'd be 1 up, so it'd be 1 right, 1 up. So 2, 3 is also a point. You can substitute it in if you want. You certainly can. But 2, 3 is also a point. Now you can either substitute in -1 or 3. You choose which one you want. Let's go with 3. I like positive numbers. They're a little bit easier to work with. Less mistakes. So 3 squared minus 2 times 3 plus 3. Again, I'm using this equation up here to substitute in, or that function. So 3 squared is 9, minus 2 times 3 is 6, plus 3. 9 minus 6 is 3, plus 3 is 6. So y is 6. So when x equals 3, the y value is 6. And so we have 3, 6. And then since it's symmetrical, -1 is 2 away from 1 on the vertex, the x value. So -1 is also have to be at 6. And now let's draw our graph. Cool. And there's your graph. Now on to second page. Find the characteristics. Domain, how far left and how far right? Well, that's going to be -infinity to infinity. That keeps going left and right. The minimum or range, the y value, the lowest y value is at 2, and it goes up to infinity. Increasing interval, so label in the graph from left to right, it's going down. So this is decreasing and then increasing. We want increasing first, so it's an increase from 1 to, and then it goes to the right forever to infinity. It decreases from left to right from -infinity to 1. Real solutions, where's it cross the x-axis? Oh man, doesn't cross the x-axis anywhere, nowhere. Doesn't cross the x-axis at all, so none. Please don't leave it blank. Y-intercepts. Well, that's an easy one. 3. So 0, 3. Axis of symmetry. Right here at x equals 1. It's the x value of the vertex always. Is it a maximum or minimum point? Well, the vertex is a minimum point. If it was maximum, it would be upside down. So it's a minimum. And end behavior. The left end of the graph is x is going to negative infinity, and the y value is going up to positive infinity. The right side is going to the right forever, that's positive infinity, the x value, and it's going up. So it's going, x is going positive infinity, it's going right, and it's going up to positive infinity. All right, draw 2 quadratic graphs with a value greater than 0. So it would look something like 2x squared or 1/3 x squared. The a value on the x squared has to be a positive. And what does that do? It means it's a quadratic and it's not reflected. So you can draw really anything, any U-shaped graph that is pointed up, not upside down. If it was a is less than 0, then it would be upside down. Something looks like that. So hope this helped. Come with class with